Good morning, one and all. Every now and then, man's mind is stretched by new ideas or sensations and never shrinks back to its former dimension. Innovation is required for the success and for the good health. Innovation is taking two things that exist and putting them together in a newer way. Nanotechnology is one of the such innovations is receiving a lot of attention of late across the globe. Today's presentation, we have made a small effort to improvise the properties of the denture-based resin by incorporation of the nanoparticle. Colonization by different pathogenic fungi and bacteria are common problem in denture virus, leads to denture stomatitis and dental caries. The concern about the presence of the denture-related microbes does not only stem from the fear about the oral hygiene, but also about the general systemic well-being of the denture wearer. There is a growing evidence that the denture-related microbes may also initiate some serious pulmonary and gastrointestinal infections. Many attempts were made to decrease the microbial count on the surface of the denture-based resin. One of them is incorporation of the nanoparticle. As we all know, titanium dioxide nanoparticle has inbuilt photocatalytic activity. So it is widely used as a self-cleansing antimicrobial material in wide variety of applications like in industry food packaging, coating medical devices, and also environmental cleaning like cleaning of the wastewater, cleaning of the air, etc. The limitation of the titanium dioxide nanoparticle is that its photocatalytic activity is initiated by the UV rays, which comprises about 5% of the sunlight. So to convert this UV range to visible light range, which activates the photocatalytic activity of the titanium dioxide, some of the vital ions like copper, nitrogen, or silver, which can be incorporated. By this doping, the UV ray spectrum can be converted to visible spectrum, where the photocatalytic activity of the titanium dioxide nanoparticle can take place. So in our study, we have doped titanium dioxide nanoparticle with the silver ions, which itself has got antimicrobial property. So coming to objective of my study, first thing is doping of the titanium dioxide nanoparticle with the silver, phase analysis using Fourier transform infrared spectroscopy and X-ray diffraction to evaluate the effect of silver doped titanium dioxide nanoparticle on carcinogenic bacteria and Candida albicans, and comparison of the antibacterial and antifungal effect at different concentrations. The material used for my study are basically polymethyl methacrylate resin, that is polymer and liquid is used, and titanium dioxide anatase nanopowder 99.7%, and silver nitrate that is used for doping. In this method, we have used ex situ method of doping, where to create 1% weight of silver doped titanium dioxide, we have taken 1.9 millimole solution of silver nitrate in 100 ml ethanol, and 1 gram of titanium dioxide nanoparticle will be added to the solution under constant magnetic stirring. The resulting solution will be constantly stirred for 6 hours at room temperature and is aged for 24 hours. Finally, the solution will be dried at hot air oven at 80 degrees centigrade overnight, and it's calcined at 450 degrees centigrade for 5 hours. This is how the magnetic stirring is done. Then it is allowed to settle. Then we place it in hot air oven for it to dry. Once the doping is done, it is examined under XRD and FTIR to see whether it is done properly or not. That is done in Indian Institute of Science, Bangalore, and the values showed that there is proper doping of titanium dioxide nanoparticle with a silver. Then we prepare the specimen. Mold spaces for the specimen will be prepared using backspaces 5 into 5 into 2 mm according to AD specification number. Then we added silver doped titanium dioxide nanoparticle at 0 weight percent, 1%, and 3 weight percent by weight. The polymer monomer then will be mixed according to manufacturer's instruction. After curing, the samples are trimmed, sandpapered, and polished. This is how the specimens are obtained. If you observe here, the control group has a good pink color, whereas when we incorporated 1% silver doped titanium dioxide nanoparticle, the color changed little black to chocolate brown. This is one of the drawbacks of the study. But when it is compared with the antimicrobial test, it will be compensated. The antibacterial test is carried out by using the following three groups, that is one for Streptococcus mutant and one for antifungal. It has three groups, that's group A, B and C with the 15 specimens each and different weight percent of silver dope titanium dioxide, that is 1%, 3% and with a 0 weight percent of that is the control group. Streptococcus mutant and Candida albicans will be in a subculture at BHIA and Seborrhoea dextrose agar respectively. Bacterial plates will be incubated at 37 degrees centigrade and 48 degrees centigrade for 48 to 72 hours, and plates will be incubated at 25 degrees centigrade for 48 hours. All test specimens will be disinfected by immersing in 70% ethanol for 5 minutes and washed in a sterile water. Then it will be incubated in sterile water for 1 hour to remove the alcohol residue. The sterile BHAB and STB will be inoculated with 1 into 10 to the power 8 and 1 into 10 to the power 7 colony forming unit of Streptococcus mutant and Candida albicans at respective temperature. And next day, BHIB and STB will be inoculated with the test specimens in a separate container and media will be incubated in the respective growth condition. Then it is exposed to the light. The Philip visible light is used, 60 volt Philip bulb is used. This is how the inoculation is done. And when we observe the colony forming unit, it is found that compared to control group, there will be reduction in the colony forming unit at 1%, whereas drastic decrease in the colony forming unit when they use 3%. That this is observed with the Streptococcus mutant as well as with the Candida albicans. These are the test specimen, the plates inoculated with the test specimens. You can see the colony forming unit which is formed. This is for Streptococcus mutant and these are for Candida albicans. To conclude, compared to 1% and 3% silver dope titanium dioxide nanoparticles, 3% has given better antimicrobial activity calculated using colony forming units. A lot of strategies have been applied to reduce the potential bacterial and fungal pathogens such as denture cleansers and denture material antimicrobial modification. These concerns suggest that need for novel modified denture material, especially one with the antimicrobial property. This can be achieved by smearing a nanotechnology concept. Thank you, Vanna.